పడుకున్నట్టు.
Good afternoon to one and all. Good afternoon. Good afternoon. So last class we discussed about that quadrature amplitude shift keying. Actual name for that one is quadrature amplitude phase shift keying. When we compare QA PSK with previous BPSK and QPSK and MRA PSK, in PPSK, QPSK, MRA PSK, symbol to symbol only phase difference that can be present, whereas in QA PSK, quadrature amplitude phase shift keying, both amplitude as well as phase also varied from symbol to symbol. So the main advantage of this one is this system QA-PSK modulation system is more immune to noise. So that is the advantage of that one. Then previous class we compared 16 array PSK and 16 QASK system. In that one, the distance between the two symbols that can be greater in QASK system and compared with 16 array PSK system. The distance between two symbols are greater or more than that other system. That indicates that errors, whatever is less when compared with other system. That means QASK 16 QASK system is has a less errors compared to bit errors compared to 16 array PSK system. Okay, that is the advantage of QASK system and compared with the PSK systems. And bandwidth is same for both the cases. The bandwidth the same. Okay, so here next another now we will discuss about that in this class binary frequency shift keying. Here we can discuss that binary frequency shift keying. So the definition for frequency shift keying is the frequency of the carrier signal is shifted or varied in according to the data signal. The data signal is nothing but a message signal that is in the form of digital form. It consists of zeros and ones. So if there is a one is there, the frequency of the carrier signal is increased, and if there is a zero, the frequency of the carrier signal is reduced. So that is an binary frequency shift keying, BFSK. At a time here, we can transmit only one bit at a time, BFSK. Like PSK, BPSK. In BPSK, symbol consists of one bit. Here, one is present, zero phase shift of the carrier, and zero is present, 180 degrees phase shift takes place. Similarly, here, instead of changing the phase, here the frequency of the carrier signal is changed. The one is there, the frequency is increased, and zero is there, that is frequency is reduced. Here now I will share my screen and then we can proceed the lesson. Okay. My screen is visible to you? Screen is visible to you? Please respond. Please.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Now I will start the lesson. The binary frequency shift keying. Once again, I repeat the definition for BFSK.
ఆ తలుపు తీసే ఇది తొక్కబోతుంటే అది ఎందుకు వేసావు?
Okay. Please, ready? Are you ready for the class? Okay. Shall I start? Okay. Once again, I will repeat the definition for BFSK. Frequency shift keying. The frequency of the carrier signal is shifted according to the data signal. The data signal is in the form of digital form. It consists of ones and zeros. So here are drawn that waveforms. Here this is a data signal, D of t or B of t. Anyone here we can represent. So for sake of this one here, D of t data signal. So the data is 1, 1, 0, 0, 1, 0. The duration of each bit. The duration of each bit is TB, TB duration. TB duration. This is the carrier signal. This is a carrier signal. Carrier. Okay. So this is a carrier signal. The data signal is one is there. The frequency of the carrier is increased. So here we can observe that the frequency of the carrier is increased. Actually here only one cycle is there. Here the frequency is 1.5. That means that indicates that the time period that can be reduced. 1/t indicates that frequency. The frequency is increased. Again here that is 1. Again here the frequency that can be increased. And again here there is a 0. The frequency is reduced. So only approximately half cycle is present. The time period that can be increased. That indicates that frequency reduced. Similar way 0, the frequency also reduced. Again 1 is there here, the frequency that is increased. And again here, so there is a 0, the frequency that can be decreased. So according to that here, the 1 is there, the frequency is shifted to higher frequencies. 0 is there compared to that carrier frequency F0 only. So if the 1 is there, F0 plus some F, small amount of frequency that can be increased. If that is a 0 is present data, F0 minus some minus F, that is the frequency that can be reduced. That is the key concept that can be present in frequency shift keying. So in binary frequency shift keying, like BFSK, only one bit is transmitted at a time. So here we can write the equation for that BFSK, binary frequency shift keying. Generally, the carrier equation is, we all are familiar with that carrier equation. Root of PS cos of omega naught t.
మ్యామ్ వెయిట్ చేస్తున్నారంటే అలౌ చేయండి మ్యామ్.
Okay, okay. Okay. 1:10 అయిపోతుంది. ఇప్పుడు వరకు లేట్ అయిందే. Why so many members are joined very late? Okay, the carrier signal here we can represent. The carrier signal, how to represent the carrier signal here? That is general equation, root of PS cos omega naught t. The frequency of that signal is nothing but, so F0, that is an instantaneous frequency, angular frequency which is omega naught. So here, then that is the carrier signal. And here you can write, according to the data signal, how the carrier signal is present. That equation for BFSK, binary phase shifting, is root of PS cos of omega naught t plus d of t into small omega t. So here we can observe that the d of t is an, here d of t is a data signal, that is an bipolar signal. That means d of t represents data signal. So here 1 is there, logic 1 indicates that plus 1 volt, and logic 0 indicates that minus 1 volt. That's why I am representing the waveform like this. So this is the plus 1 volt, this is the minus 1 volt. Okay, this is the data signal. D of t is plus 1 volt, minus 1 volt. So omega t, here omega indicates that the amount of frequency, small amount of frequency. Okay, so here if the d of t is plus 1, so that equation is, Emma, anybody waiting? Very good. Okay, I will continue. So here we can write d of t is plus on here. We write this equation, root of 2ps cos of omega naught t plus omega t. Again here we can write this equation, root of 2ps cos of omega naught plus omega of t. So this is when d of t is equal to 1. Let us assume omega naught, frequency 2 pi. Here also some value 2 pi. So omega naught t here, f naught is equal to some 10 megahertz. Carrier frequency is 10 megahertz. If 1 is present, 10 megahertz plus some 10 kilohertz. So omega is indicates that 10 kilohertz. So that means this frequency is increased when 1 is there, data is present. Again here, if d of t is minus 1 volt, that equation is root of ps cos of omega naught minus omega t. That means here 10, according to example, 10 megahertz minus 10 kilohertz. That means the 1 is there, the frequency is increased. Generally that indicates that omega h. And here there is a 0, logic 0, data is 0, that is minus 1 volt. Here we can indicate that is omega L, low frequency. So that's why here we can write this equation again. If d of t is equal to plus 1 volt, d of t is 1 volt, d of t is 1 volt, that is logic 1. Here we can write the equation is the BFSK of t. ఎవరు మ్యూట్ చేయట్లేదమ్మా, మ్యూట్ చేయండి ప్లీజ్. ప్లీజ్ నాయిస్ వినిపిస్తుంది, ఎవరియో మాటలు వినిపిస్తుంది, ప్లీజ్ మ్యూట్. Root of 2ps cos of here we can write like this equation. Cos of omega ht, omega ht, and minus 1 volt, d of t is minus 1 volt. This equation, root of 2ps cos of omega lt, where omega ht, omega h is nothing but omega naught plus omega. Emma. Where omega L is omega naught minus omega. Please note down this equation. This is very, very important. This is the equation for BFSK. Please mute. Dinesh, voice వినిపిస్తుందమ్మా, మ్యూట్ చేయండి. Okay, so this is the equation for BFSK. Root of 2ps cos omega ht, root of 2ps cos omega lt, where omega h is equal to omega naught plus small omega, and omega L is equal to omega naught minus small omega. Okay, then so here we can generate this type of signal. According to that data signal, we convert this data signal d of t is into unipolar. So actually, in this equation, D of t is a data signal that is a bipolar signal. That means D of t, logic 1 plus 1 volt, logic 0 minus 1 volt. That is a bipolar. So we convert that signal into unipolar. Then only we can easily generate BFSK signal without any deviation and without any distortion. So what is the further step here? We convert the data bipolar signal into unipolar signal. So here we can represent PH of t is an unipolar of the data signal, higher data signal. PL of t is a 0 when a minus 1 volt is there. Here we can convert that is into unipolar. Suppose D of t is plus 1 volt is there, that is logic 0. At that time PH of t is 1, PL of t is equal to 0. Please note down parallelly, these are very important for this BFSK. And D of t is minus 1 volt, that is at logic 0, PH of t is 0 and PL of t is 1. That's why here D of t is an bipolar, we convert that into unipolar. So bipolar indicates that the voltage waveform is changes between plus 1 volt and minus 1 volt. Unipolar indicates that only the signal is in 1 to 0 here we can present. This is a unipolar. Now we converted the data signal into unipolar. Actual form input గా ఇది తీసుకుంటాము. దీని నుంచి మనం ఏం చేస్తాము, యూనిపోలార్ గా కన్వర్ట్ చేసుకుంటాం. 1 and 0 volts దగ్గర పెట్టుకుంటాం. ఆర్ యు అండర్స్టాండ్? ఏమో అర్థమైందా ఇక్కడ? అదే బీపీఎస్కి అనుకోండి, బైపోలార్ సిగ్నలే ట్రాన్స్మిట్ చేసేస్తాం. There is no problem for generating that BPSK signal, but BFSK signal have to generate that BFSK signal according to our form. ఈ form లో మనకి రావాలి అంటే here we can convert that bipolar signal into unipolar signal. Okay, my voice is audible to you? Hello? Anybody respond?
Yes, ma'am.
Okay. ఎలా మనం బైపోలార్ నుంచి యూనిపోలార్ కి చేశాను చూసారు కదా. నౌ హియర్ వి కెన్ జనరేట్ ద బిఎఫ్ఎస్కే సిగ్నల్. Generation of BFSK signal, please note down. BFSK signal generation, and that is nothing but a transmitter. So here we can use two balanced modulators in this BFSK generation. Balanced modulator 1, balanced modulator 1. It has two inputs. For balanced modulator has in two inputs, and this is another balanced modulator 2. So one is here, root of 2 by TB is into cos omega HT. Omega HT. And another input for this balanced modulator 1 is root of PS into TB PH of T. Then for second balanced modulator, the signal is root of 2 by TP cos of omega LT, and second input for this one is root of PS.
మేడం ఎలా చేయమంటున్నారు మేడం?
చేస్తాను. Root of PS TP PL of T. Okay. Then these two outputs are input to the adder. Here we can use this as an adder. The output of the signal is BFSK signal. Okay, please note down this. Why you are coming late? 29 F3. Emma, already 25 minutes left. Why you are coming late? Okay, please join. So this is the block diagram to generate FSK signal. This is very, very important. Here we can understand the operation of these BFSK generation or BFSK block generate transmitter block diagram. Here the input is an carrier root of 2 by TB cos omega HT, where omega H here initially we can design this omega H, that is equal to omega naught actual carrier plus here some small amount of the frequency. Here we can add, that is omega H. Here omega L is equal to omega naught minus omega. This is a high frequency term. That's why high indicates it. H indicates that high frequency. L indicates that low frequency term. So here we can generate that data according to that frequency signal, FSK signal according to the data signal. So this is the form. D of T is converted into unipolar. That is, the bipolar is converted into unipolar. Suppose here D of T is +1. Only high frequency component here we can generate. BFSK is equal to equation, that is equal to here root of 2PS cos of PH of T here. What is the output equation for this? Root of 2PS PH of T cos omega HT plus root of 2PS PL of T cos omega LT. So this is the equation for BFSK. So if D of T is +1 volt, so this term is 0. PL of T is equal to 0. Only this term is present. Whereas in D of t is minus 1 volt, this term, low frequency term is present. This term is 0. So like that here we can transmit the signal. Okay. So this is the equation for BFSK signal. Please note down. Then now, Emma, are you followed? How we can generate BFSK signal? Note చేసుకున్నారా?
Yes,
Please
ma'am.
respond. Okay. Shall I start next one?
Yes, ma'am.
Okay. Next. Here we can find out the bandwidth of BFSK signal, because the bandwidth and the distance between the two symbols are very, very important to compare that one system is with the other system. Which one is advantages? Which one is an disadvantages? Where we can use this type of modulation technique. According to their characteristics, here we can use the modulation technique. That's why here we can find out the bandwidth of BFSK signal. So please note the bandwidth of BFSK signal. So for calculating that BFSK signal here, when this equation is compared with that BPSK signal, BPSK signal go almost all that is the same. Root of 2ps cos of omega naught t when plus 1 is present. So if that is a data minus 1 volt is present, minus root of 2ps cos of omega naught t is there. So the difference between the both the signals in BFSK and BPSK signal, the D of t data signal is bipolar, that is directly transmitted. But in this case, BFSK, that data signal is converted into unipolar, then the signal is transmitted. That is the difference for BFSK and BPSK. For calculating bandwidth of BPSK, directly we can take in that signal, that is in bipolar signal. But in this case, so the data signal is in unipolar. Again, here can convert the signal into bipolar. After that, you have to calculate the power spectral density of the signals, and from that one, have to calculate bandwidth of the signal. Are you understand? మనం ఏం చేస్తాము, డి ఆఫ్ టీ అనేది బైపోలర్ సిగ్నల్ ని డైరెక్ట్ గా ఇక్కడ మనము బిఎఫ్ఎస్కే సిగ్నల్ డి ఆఫ్ టీ యూజ్ చేసి మనం జనరేట్ చేయలేదు. బికాస్ ఆఫ్ జనరేషన్ ప్రాబ్లమ్స్ ఉన్నాయి కాబట్టి డైరెక్ట్ గా డి ఆఫ్ టీ బైపోలర్ సిగ్నల్ యూజ్ చేస్తే, దాన్ని ఏం చేస్తాము, డి ఆఫ్ టీ బైపోలర్ సిగ్నల్ ని యూనిపోలర్ గా కన్వర్ట్ చేసుకొని, సో దట్ యూనిపోలర్ సిగ్నల్ యూజ్ చేసుకొని బిఎఫ్ఎస్కే సిగ్నల్ ని మనం జనరేట్ చేసి ఆ సిగ్నల్ ని మనం ట్రాన్స్మిట్ చేస్తాం. బట్ బ్యాండ్విడ్త్ క్యాలిక్యులేట్ చేయాలి అంటే again here can convert that unipolar signals into bipolar signals. Okay, then PH of t and PL of t are the unipolar signals. We convert that into bipolar again here. So here we can indicate that PH of t and PL of t are unipolar. That is, that voltage levels are between 1 and 0 only. Unipolar. Convert that into bipolar. So therefore, PH of t equal to bipolar ante +1 -1 బైపోలారిటీస్ రెండు ఉంటాయి, టూ పొలారిటీస్ మధ్యలో బైపోలర్. So here pH dash is plus 1 volt or minus 1 volt. PL dash either plus 1 volt minus 1 volt. Suppose here pH of T is
Madam, screen share outlet, madam.
screen share outlet. Okay.
Yes, ma'am.
I will do.
మ్యామ్ కొంతమంది నెట్ ప్రాబ్లం వచ్చి వెనక్కి వెళ్ళిపోయారంట, అలా చేయండి మ్యామ్.
Allow చేస్తాను. Okay. Now I am sharing my screen. Emma, now my screen is visible to you?
ఎస్ మ్యామ్.
ఓకేనా?
Yes, ma'am.
ఇక్కడ ఏం చెప్పానంటే pH ఆఫ్ టీ అండ్ PL ఆఫ్ టీ ఈజ్ యూనిపోలర్ కదా. ఇప్పుడు మనం బైపోలర్గా చేస్తాం. బైపోలర్గా కన్వర్ట్ చేసుకోవాలి అంటే అగైన్ pH ఆఫ్ టీ ఈజ్ ఈక్వల్ టు 1/2 ప్లస్ 1/2 pH డాష్ అనేది సబ్స్టిట్యూట్ చేసుకోవాలి. అప్పుడు ఆ ఈక్వేషన్ ఏమవుతుంది, బైపోలర్ అవుతుంది. అగైన్ హియర్ ఆల్సో PL ఆఫ్ టీ ఈక్వల్ టు 1/2 ప్లస్ 1/2 PL డాష్. ఇక్కడ pH dash and PL dash are bipolar. That means that values are from plus 1 volt to minus 1 volt. How that can be convert that into unipolar to bipolar అంటే ఒకసారి చూడండి. pH of T is plus 1 volt అనుకోండి. At that time pH dash is equal to plus 1 volt. Here we can substitute this one plus 1 volt, 1/2. So pH of T is equal to ఎంత వస్తుంది, 1 వస్తుంది. Again pH dash is equal to minus 1 volt అయితే ఇక్కడ ఏమవుతుంది, minus 1/2 plus 1/2, that cancel. pH of T is equal to 0. So pH dash is in bipolar and here this pH of T is in unipolar. So that's why here we can substitute pH of T is equal to 1/2 plus 1/2 into pH dash. So that is in bipolar of that. Then in the place of pH of T, without changing any status here, we can substitute this one into that equation. Obviously that equation is in bipolar. Okay. Again here you can write that equation. BFSK equation is equal to, please note down, me write nama, root of 2PS. In the place of pH of T, here you can write 1/2 plus 1/2 pH dash into cos omega HT plus root of 2PS. Again in the place of PL of T, here we can write 1/2 plus 1/2 PL dash into cos omega LT. Okay, this is the equation. We convert that unipolar equation into bipolar equation. So, okay, this is a bipolar, in the form of bipolar. So now here we can expand this equation. We can expand this equation. Root of 2PS and 1/2 cos omega HT plus root of 2PS 1/2 pH dash cos omega ht plus root of 2ps 1/2 cos omega lt again here root of 2ps 1/2 pl dash cos omega lt. So this is the equation after expanding that above. So now here we can calculate the power spectral densities of this equation. So here we can observe that terms that are present in this equation is this is root of 2ps 1/2 cos omega ct. This is nothing but some amplitude with cos signal, ordinary cos signal. There is a sign that is a cos signal with the constant amplitude, RMS voltages and amplitude. This is total amplitude with cosine waveform. Here we can indicate that this is an data signal or bipolar and high frequency term. Similarly here also this is an amplitude a, some let us assume a cos omega lt. So that is ordinary carrier like carrier signal. And here also this is an low frequency carrier signal with bipolar data. So you all are familiar with if there is an a into some cos omega naught t, that spectrum of that signal is like this. You all are familiar with this one. So how we can write this is an a cos of omega naught spectral components. Spectral components రాయాలి అంటే దాన్ని ఏం చేస్తారు, దట్ ఈస్ అన్ ఎక్స్పోనెన్షియల్ ఫార్ములా రాస్తారు. e to the power of j 2 pi f naught t and e to the power of minus j 2 pi f naught t divided by 2 like that. Similarly here what are the components we are obtained at f naught is an one component and minus f naught another component is there. So this is a center frequency 0. This is a spectrum of or spectral components of a cos omega naught t. For both the cases, for this case and for this case, you will get this type of spectral components. But for this case, root of 2ps 1/2 ph dash, this is in bipolar. For this in bipolar case, how we can find out the spectrum? Already you are done that derivation for PSK, get that spectrums are like this here, that are like this. So here we can draw this one for above 1. So here we can indicate that the power spectral densities of this
స్క్రీన్ షేర్ అవట్లేదు మ్యామ్.
screen share out is the problem. Now I am shared. So here we can observe that for this case, here we can calculate the power spectral density of this one. This is on bipolar. We have to follow the same procedure as like in BFSK. That is also a bipolar signal. So here we will get that some amplitude here, amplitude for this one. And but here that frequency components, here we can indicate that. So FH center frequency plus F is there into TB. So here we can indicate TB, that is equal to pi. Here we will get pi equal to first this 0 indicates that pi into FH plus F into TB is equal to pi. Pi get cancelled. Therefore, F plus or FH equal to 1 by TB, bit duration. This is equal to FB. This is equal to FB. That means this is an FH or F, we can indicate that F. So here we can indicate that F plus FH, the distance F plus FH. What is this distance? Is nothing but FB. Here also this is an FB. The bandwidth for this PH dash term is, only this term is 2FB. 2FB. And here also, for this case, we can draw this spectral component for this term is at center, because that is center frequency is FH with some amplitude. The amplitude is equal to this one. We can simplify this one. And here, for this one, this is the spectral component for pole 1. For this case, this is a sinc function with these frequencies. The bandwidth of this term is 2FB only. Similarly, here also we come into this section and another part of this equation, that spectral components for that one is equal to. Again, here we can draw this signal. So here we can indicate that this is an FL. This is a spectral component for this one. At center frequency is equal to FL. And for this case here, we can indicate that this is an FL plus F. The frequency equal to FB. This is an FB. Again, this is also FB. This is an FB. So this is an F0 minus, FL minus F. This is an FH minus F, like that. That means here we can observe that the bandwidth. So FB, FB, 2FB for this spectrum, and for this one low frequency component, again the spectrum is FB plus FB. So that is equal to 2FB. So therefore, the total bandwidth in BFSK equal to 4FB. 4FB. Okay. Whereas in BPSK, the bandwidth is only, how much are you calculated? That is in 2FB. Whereas in BFSK, the bandwidth is equal to 4FB. Why here that is in 4FB, the bandwidth is 4FB in BFSK? Because of, here we can transmit the 1 bit, that is an plus logic 1 is there, 1 frequency band, that is high frequency. And if that is d of t is equal to logic 0, that is minus 1 volt, so you go for another frequency. So one frequency occupies 2FB and a lower frequency occupies 2 FB. Two frequencies are used here, total 4 FB. Whereas in BPSK, the same frequency, only phase are different, but if that is the plus 1 volt is transmitted, the frequency of that one is same as that. If that is data is transmitted for minus 1 volt also, same frequency. There is no difference in the frequencies. Only there is a difference in phase only. Whereas in BFSK, here we can transmit 1, logic 1, it high frequency component occupies 2 FB. Again, minus 1 volt, that is logic 0, it occupies low frequency component. Again, it occupies 2 FB. The frequencies are different. So due to that one, the high bandwidth that can be required for transmitting, that is the data in BFSK. Okay, so each symbol consists of 1 bit in both the cases, but the bandwidth for BPSK is 2 FB for 1 bit, whereas in BFSK, the bandwidth is in 4 FB. Are you understand why the bandwidths are different in BFSK and BPSK? Emma? Hello? Hello?
Ma'am.
ఓకే అర్థమైందా మనకి బీపీఎస్కేలో అయితే ఫేజ్ ఓన్లీ డిఫరెన్స్ ఉంటుంది. సింబల్స్ని ట్రాన్స్మిట్ చేసేటప్పుడు సేమ్ ఫ్రీక్వెన్సీ. ఇప్పుడు 1 అనుకోండి, ట్రాన్స్మిట్ చేయాలనుకోండి సేమ్ ఫ్రీక్వెన్సీ. 0 అయినా సేమ్ ఫ్రీక్వెన్సీ ఉంటుంది. 1కి 0కి డిఫరెన్స్ ఎంత? ఫేజ్ డిఫరెన్స్ మాత్రమే డిఫరెన్స్ ఉంటుంది. బట్ బిఎఫ్ఎస్కేలో 1 ట్రాన్స్మిట్ చేయడానికి ఒక ఫ్రీక్వెన్సీ యూజ్ చేస్తాము, సో 0 ట్రాన్స్మిట్ చేయడానికి అనదర్ ఫ్రీక్వెన్సీ యూజ్ చేస్తాము. 1 పంపించేది ట్రాన్స్మిట్ చేసేటప్పుడు 2 FB ఆక్యుపై చేస్తుంది, అండ్ 0 ట్రాన్స్మిట్ చేసేటప్పుడు అనదర్ 2 FB అనేది ఆక్యుపై చేస్తుంది. అందుకని బ్యాండ్ విడ్త్ బిఎఫ్ఎస్కేలో 4 FB ఉంటుంది, బిపిఎస్కేలో 2 FB ఉంటుంది. సో దట్ ఈస్ ద మెయిన్ డిఫరెన్సెస్. ఓకే, సో మీరు ఎన్ని ఆల్రెడీ వీఆర్ డిరైవ్డ్ దిస్ టైప్ ఆఫ్ ఈక్వేషన్స్కి ఎలా పవర్ స్పెక్ట్రల్ డెన్సిటీస్ మనం ఎలా డిరైవ్ చేయాలా అనేది మీకు ఆల్రెడీ నేను పంపించున్నాను కదా, మీరు డిరైవ్ చేయగలరా? ఆర్ యూ ఏబుల్ టు డిరైవ్ దట్ పవర్ స్పెక్ట్రల్ డెన్సిటీస్ ఆఫ్ దిస్ టర్మ్స్? ఏమా ప్రాక్టీస్ చేయండి, రాకపోతే నన్ను అడగండి. ఓకేనా? సేమ్ ప్రొసీజర్. Okay, are you understand the concept behind BFSK when compared with BPSK? Hello, please respond.
Yes, ma'am.
So power spectral density of BFSK signal na derive చేయగలరా మీరు? సేమ్ ప్రొసీజర్. మనం బీపీఎస్కేకి ఎలా చేసామో క్యూపీఎస్కేకి ఎలా చేసామో అదే ప్రొసీజర్ అనమాట. ఒకటేమో కాన్స్టెంట్ టర్మ్స్ ఉన్నాయి, ఇంకోటేమో బైపోలర్ టర్మ్స్ ఉన్నాయి. బైపోలర్ టర్మ్స్కి బీపీఎస్కేకి ఎలా చేశారో అది ఫాలో అవ్వాలి. కాన్స్టెంట్ టర్మ్ ఉన్నది కదా, దానికి స్పెక్ట్రల్ కాంపోనెంట్స్ డ్రా చేస్తే సరిపోతుంది. ఓకే, నెక్స్ట్ క్లాస్ we will discuss about the transmitters and receiver of BFSK. Okay, shall we stop here? Okay, thank you.
Thank you.
Thank you.